Hi students, so I'm working on the questions from section 7.1, which is where we're learning how to do stoichiometry. So I'm not going to do all the questions from page 244 because once you know how to do the first one, you should be able to do the other ones as they're quite similar. So let's work with number 11. And so we have ammonium sulfate solid reacting with 2 sodium hydroxides to produce sodium sulfate, aqueous, plus 2 ammonia, which is a gas, plus 2 waters. Okay, it's a double displacement reaction resulting in further decomposition. So it's saying what mass of sodium hydroxide is required? So we want to know this here. Okay, let me set this up for you. I like to work going downwards. So I set up a table. I know I need to find out the mass of sodium hydroxide. So you use mass, molar mass, number of moles, and then I have this other part on the table where I just say it's xn, and that is where you deal with the coefficients. Okay, so that's fine. So you're going to hear some stuff in the background. All right, so it says what mass of sodium hydroxide is required to react completely with 15.4 grams of ammonium sulfate? So this is what we can fill out from the question, but what you can really fill out now is the molar mass. So that's what's not given to you in the question, but we know that we can get it off of the periodic table. Okay, so we have 2 nitrogens, 14.01, plus 8 hydrogens, so 8.01, plus 1 sulfur, 32.07, plus 4 oxygens, which are 16.00. So I get a total molar mass of 132.17 grams per mole. And while I'm here, I'm just going to fill in for sodium hydroxide. So 22.99 plus 16 plus 1.01 is 40 on the dot. Okay, so the wonderful thing is because the mass and molar mass are related with each other, you can do number of moles as mass divided by molar mass. So when I go down, the way that I get the number of moles is I'm dividing this first number by the second number. And the table really sets it up for you here too. It's like a fraction. So 15.4 divided by 132.17, and I get 0.11652 moles. And so do you see how I'm using more numbers than I need to for significant digits, but that's fine. Now, you might be confused by this part, xn. What I do is I have to look at my coefficient. So because this coefficient is 1, when you're going down the table, you're always dividing. So I'm going to divide by the coefficient, which is 1. So nothing is going to happen here. All right. This is the number you're going to bring over. Okay, because you want to figure out how much sodium hydroxide you need. And so if you have 0.11652 moles of ammonium sulfate, then you need to figure out proportionally how much sodium hydroxide you need. Okay, so now that we're going up the table, we're going to be multiplying. So you're going to multiply by the coefficient. So in this case, multiply by 2. So multiply the answer by 2, 0.23303 moles. Then because I'm going up again, I'm going to multiply by the molar mass, 40. And I get 9.32 grams. Okay, so therefore 9.32 grams of sodium hydroxide is required. Great. Okay, so try the other two on your own. And then let's look at 248, number 19. I'll do it in black. So number 19, nitrogen gas is produced in an automobile airbag. It is generated by the decomposition of sodium azide. So that is how airbags inflate is through this decomposition reaction, and it's nitrogen gas. So to inflate the airbag on the driver's side of a certain car, 80 grams of nitrogen is required. What mass of sodium azide is needed to produce 80 grams of nitrogen gas? So let's set up our table.
Yeah, you want to play around with your wood a bit? Or?
Yeah. So we're going to do mass, molar mass, number of moles, and again the coefficients. No. So what do we have from our question? So we have 80 grams of sodium, or sorry, of nitrogen gas, and we don't need to worry about sodium at all.
He won.
Okay, so let's fill out, what we need to find out is this mass. You can hear my family in the background. So the molar mass of nitrogen. So nitrogen is a diatomic molecule. Oh, I get to turn off the TV too. I get to turn off the TV. Woohoo. All right, so 2 nitrogens is 14.01 times 2, so it's 28.02 grams per mole. And sodium azide is 1 sodium plus 3 nitrogens, and I get 65.02 grams per mole. All right, so we're going down the table. We get to divide. So I'm going to divide 80 divided by 28.02. And I get 2.8551. And now we're going to divide it by 3, the coefficient of nitrogen, divide by 3, 0.9518. Bring it over here, 0.9518. So do you see how I'm not manipulating it at all as I bring it over? Sometimes I goof and I just multiply by the coefficient. Okay, so now as we're going up the table, we multiply. So I'm taking 0.9518 multiplied by 2, and I get 1.9034 moles. And then again, I'm going to multiply by 65.02. And I need 123.75. So following significant digits, I need 124 grams. Therefore, 124 grams of sodium azide is required. And I hope you guys never have to require sodium azide and have to use your airbags. Okay, so it says, oh, how many atoms of sodium are produced? Guess what? So when I erase this part over here, we can actually work on it. I'm going to erase this too. If you notice, I don't really care about therefore statements as long as you, like for this question, you do need to put just therefore mass equals 124 grams because the tables they're very confusing for me to mark. So I'd rather you guys just tell me what you know. Okay, so all we have to, or sorry, tell me what you figured out. We're starting at this point here. All right, we need to find out how many atoms of sodium are present. And so we have this number here. We're moving up the table. I have to multiply by the coefficient. So I'm going to multiply by 2. 0.95 0.18 times 2 is 1.9036 moles. And I'm going to stop here because if I want to find the number of things, it's number of moles times Avogadro's number. So I'm going to take 1.9036 moles, and I'm sure you guys have, this is a distant memory, but 6.02 times 10 to the 23 atoms per mole. And then this way I can cross out that. So multiply 6.02 times 10 to the 23. And following significant digits as well, so 80.0, there's 3 significant digits. So I'm going to put 1.15 times 10 to the 24 atoms of sodium are produced. Okay, number 22. Let's have a look at that one. Ammonium gas reacts, oh, guess what? I just showed you how to do this one. I'm gonna let you guys do that one on your own. Hopefully everything works out with that. And of course my computer's frozen. Back to meeting.